Hello and welcome back to Algebra, Chapter 2, Section 5. We're talking about compound inequalities. Alright, compound inequalities combine two sets of inequalities by an AND or an OR statement. Okay, for an AND statement, the graph shows the intersection of both graphs. So let's look at a couple of inequalities here. X is less than 4. You can number these 1, 2, 3, 4, 5, 6. And then x is less than 4. Here's 4. That's an open circle going this way. Then here we have x is greater than or equal to 2. That's a closed circle at 2 going to the right for all numbers larger. The intersection of those two, if x is greater than or equal to 2, so we're going to start here, can't be on the left side of this, going this way, and it has to be less than 4, so it can't be on the right side of 4, going this way. So it looks like an old school barbell with these two circles at either end. Make sure they're filled in or closed the way they were in the original. So it's the intersection of these two graphs. If an OR statement, it can be one or the other. So here we have x is less than 7. Label this, say 5, 6, 7, 8, 9, 10. So x is less than 7. Here's 7. Open circle at 7, going this way. Then x is greater than or equal to 9, closed circle at 9, going that way. The final graph is both of these together, so open circle going to the left, starting at 7, closed circle at 9, going to the right. And that's the OR statement. Notice a compound statement I can write together in one expression like this. For an OR statement, you can't do that. You have to write both and put the OR in between them. Also notice here that both our signs are pointing to the left. We start with the smallest number on the left side, the largest number on the right side, and both my signs point to the left. Right, here's an example. A number x is greater than -8 and less than or equal to 4. Okay, we're going to write this as a compound inequality. So I'm going to start with the smallest number, -8. Number is greater, and then my largest number 4 goes on the other side. X goes in between. Now I've got to decide on the signs. Less than or equal to 4, so that one's pretty simple here. Less than or equal to. And then x is greater than -8. Now remember I said our signs have to point to the left if it's going to be an AND statement, so it's going to have to point that way, but let's make sure that's true because it said greater than. Reading from the x, this is the greater side. -8 is less than x, so x is greater than -8. If I was to graph that, I can put -8 somewhere here, -4, 0, +4, let's go by 4s. That would work. And then we have an open circle here and a closed circle at 4, because 4 is included. Okay, solving AND inequalities. If I just showed you a part of this, like without this -3, if you just looked at this statement, that would be pretty easy to solve, right? Just add 2 to both sides. Same thing if I just showed you this part of it. Add 2 to both sides. Well, it's exactly what you're going to do. We're just going to add 2 to this, and here, and here. So solving a compound inequality. Notice the inequality signs here and there. I've got to do it on every side of the inequality sign. So that gives me -2 is less than x, which is less than 5. Quick check, -2 is less than 5, so I have it in the right order. My signs are pointing to the left, so I can put -2 here, 0 somewhere there, and 5 is approximately there. These are both open circles because that number is not included. That line goes in between the two. There we go. Solving OR inequalities. That just means I have to solve each of them. So plus 5 because I'm solving for the 3y. 3y is less than negative 3. Divide by 3. Sign doesn't flip because I'm dividing by a positive number. Y is less than negative 1. Or plus 1 plus 1. 2y is greater than 6. Divide by 2 on each side. Y is greater than 3. So negative 1, then 0 somewhere there, and 3 here. Now it's OR. Y is less than negative 1. So open circle at negative 1, pointing this way. Greater than 3, open circle here, pointing that way. That's an OR inequality. Okay, a couple of special cases here. If we have x is less than 5, so here we have 5, 6, 7, 8. X is greater than 8. So this way or this way. And it says AND because it's in one statement. So this is an AND statement. It has to fulfill both of these. What number fulfills both less than 5 and greater than 8? There is no number, so there is no solution to this. Okay, notice these signs are both pointing to the right. We have the smaller number on the left, so there's no solution. Now look at this case right here. Both signs are pointing in a different direction. I have 5, 6, 7, 8. Okay, x should be greater than 5. Okay, so here we have open circle greater than 5, so going this way. This says x should be greater than or equal to 8. So closed circle here, going this way. What numbers fulfill both of these statements? Which numbers are both greater than 5 and greater than or equal to 8? Well, everything from here on out is where these two overlap, which means the answer to this is just x is greater than or equal to 8. This graph right here, from here going this way, is the solution set. Okay, a couple of OR special cases. We have 4, 5, and 6. X is greater than 4. All right, open circle here to the right. Or x is less than 6. Notice that these overlap. It can either be this one or that one. Is there any number that's not included? Well, no. It can be any of those. It could be this or that one. It means the solution here is all real numbers. This last example, we have 5, 6, 7. X is less than 5. Less than 5, or x is less than or equal to 7. What numbers fulfill both of these statements? It could be this or that. Well, less than 5 is already covered in it being less than 7. That includes all of these. So the answer here is x is less than or equal to 7. This would be the final graph because all of these numbers are included in that graph. X is less than or equal to 7. All right, and that's all for today, folks. We've had a lot of fun. Check in again next time.